Hi everyone, welcome to my channel, Tutorly Test Prep. Today we'll be going over 7 hard problems for the June 2024 DSAT Problem Sette number 7. The goal of the Problem Sette series is to provide an original worksheet of challenging problems right before the test date. This gives students the opportunity to push themselves while also reviewing a variety of topics. Please download the worksheet for free using the link in the description and attempt the problems yourself before watching this video. Let's get started. Okay, question number 1. So I go over a good handful of these concepts in my video Ottocento number 13, Basic Quadratics. So definitely go and check that out. All right, so first thing, pretty much the only thing they tell us is that the vertex is -5, -12. So that means this guy is H and this guy is K. And it has no x-intercepts. So I'm going to make a little picture. So -5, -12, that would be in quadrant 3, kind of down here. Just kind of think like, oh, -5, -12, somewhere down here in quadrant 3. X and Y are both negative. So what we're going to do is, they tell us it has no x-intercepts. So if it were facing up, it would have 2 x-intercepts, so it can't be facing up. It must be facing down. And I go over this in the Ottocento video. If a parabola is facing down, that means that A is less than 0. So let's just hang on to that for now. That's going to be really important later. So let's go ahead and write the vertex form for this, and then we'll try to translate it to standard form like the question wants us to. So y equals a, x minus h squared plus k. Y equals a, x minus -5 or plus 5 squared plus -12 or just minus 12. Change the first sign, keep the second sign. Okay, so that's like our partial vertex form. We would really love to plug in a point so that we could find a, but we can't plug in a point because they didn't give us one. So what we're going to do is we're going to expand this guy to put it in standard form. So x plus 5 squared is x squared plus 5x plus 5x plus 10x plus 5 times 5, which is 25, minus 12. So this is, if I distribute that a, it's ax squared plus 10ax plus 25a minus 12. And if you look at ax squared plus bx plus c, I see that a is just a, b is 10a, that's what's in front of x, and c, the constant term, is 25a minus 12. So we want to find this quantity, which, for lack of a better word, I'm going to call it the sum, not the sum of solutions, just the sum, is a plus b plus c. That's what they want us to find. So here, that is going to be a is just a, b, as we talked about, is 10a, and then c is 25a minus 12. Okay, 1a plus 10a plus 25a, that's 36a minus 12. And how about, just to make guess and checking easier, those answer choices represent sum, so why don't we get the a by itself? So if I add 12 to both sides, I get sum plus 12 equals 36a. And if I divide both sides by 36, I get a equals sum plus 12 over 36. So this is what we're going to use to check the answers. So why don't I pull up Desmos and just do this really quickly with the answer choices. So let's say a as a function of the sum is s plus 12 over 36. And I'm going to start guessing and checking the answer choices. You guys can just do the arithmetic as well, like negative 19 plus 12 over 36, see what you get. So you see for all of these, the only one that gives me a negative a value rather, which is what we talked about earlier in the question down here. It's got to be negative, so that has no x-intercepts. Because it's in the third quadrant, we want it to point away from the x-axis. And it seems the only one that gives us that is answer choice A. That's the only one that gives us that. B gives us an a value of 0, which it wouldn't even be a quadratic anymore. It would be a horizontal line. And C and D give us positive a values, so that would mean it's pointing up, and it has 2 x-intercepts. Question said it has to have 0 x-intercepts. Great, let's keep going. Okay, so question 2. This is question 2. For this one, they're giving us a line of best fit for dataset P. And dataset Q is going to be created by multiplying all of the y coordinates from that dataset by 4.3. So what we're going to do is we're going to figure out the equation for line P. Then we'll use this information I highlighted in yellow to find the equation for line Q. And that'll give us our answer. So what you guys need to understand is that the actual y values we get from the dots. The predicted y values we get from the line. So this question, we're trying to find the equation line of best fit. So we actually don't care about those dots. So those are just there for context. We don't care about those dots at all. For y predicted values, we're looking like all along this line, really anywhere on this line. If there's a dot there, coincidentally, that's fine, but we don't really care about the dots at all. So what we're going to do is we're going to look at the line, and we're going to see if it goes through the corners of the grid markers at any point, or at least really close to them. So I see that for this one, this point here, that's 1, 7. I'm going to write that down. And then another point that goes through a corner of a grid marker is 3, 2. So let's write that down as well. To find the equation of the line, first thing I'm going to do is calculate the slope. This is all for dataset P. y2 minus y1 over x2 minus x1. I could label this one x1, y1, this one x2, y2. Doesn't matter as long as I'm consistent. And I'm going to do 2 minus 7 over 3 minus 1. That gives me negative 5 over 2, or negative 2.5. And that's the slope, and I'm going to write the partial equation, y equals negative 2.5x plus b. And now to find the y-intercept, because I could tell it by looking at it, but you see it doesn't really exactly go through a grid marker, so why don't I use one of my other points to try to figure it out? So why don't I plug in 3, 2? So we'll do 2 equals negative 2.5 times 3 plus b. And let's see, what's negative 2.5 times 3? That's negative 7.5. 7.5 plus b, it's a 7. Okay, now I'm going to add 7.5 to both sides. And I get that the y-intercept is 9.5. So the equation for line P is y equals negative 2.5x plus 9.5. How about I put it in kind of this statistics form, which we're going to be working with a plus bx. So 9.5 minus 2.5x. So you see it's the same as negative 2.5x plus 9.5. I just changed the order. Addition is commutative as long as you're keeping the signs of everything the same. Again, guys, it's the same thing as negative 2.5x plus 9.5, which is what we would have wrote if this were like a lines question, but it's a statistics question, so we're going to try to get it to look like this guy up here. All right, so that's the equation for line P. Now, if the y values get multiplied by 4.3, that means these guys get multiplied by 4.3 as well, because you have to multiply by both sides by that number. So the slope and the y-intercept, whatever number you multiply the y values by, the slope and the y-intercept also get multiplied by that number. So the equation for q of x, and I'll use function notation now. How about I call this p of x? So the equation for q of x is, what's 9.5 times 4.3? That's 40.85. And then negative 2.5 times 4.3. That's a negative 10.75. So you see, if we were to make this a plus bx, like the question wants us to, a is 40.85, and b is negative 10.75. So we're going to do a minus b equals 40.85 minus negative 10.75. And that should give us 51.6. And that is also equal to, the fraction would fit in the Blue Book app. So we could also put 258 over 5. I still think knowing how to find the equation of a line is an important skill to know how to do by hand, especially for a conceptual question like this. But this would be a really good one to do on Desmos. So let's jump to Desmos. And we said the 2 points for line P, line of best fit for the DSAT P. Let's make a table. It would be, what did we say, 1, 7, and 3, 2. And I'm going to do y1 tilde mx1 plus b. And if you want, I could do a plus b x1. So the a, we would multiply that to get the equation for data set Q. We'd multiply both those by 4.3. So 4.3a and 4.3b. And then we just go down here and subtract them. And we get 51.6. You guys can't see that. Let me move this up a little bit. So if I click this fraction button, it'll tell it to me as a fraction. I don't really care personally if it's a terminating decimal. I don't mind using the terminating decimal, especially for a statistics question like this. It did say round right to the nearest tenth, so if you guesstimated your points a little bit off, hopefully you still get the same answer. Great, let's keep going. Quick comment about this one, guys. You'll see I added the graph for Q of X as well. And just so you can kind of see conceptually what's happening. When we multiply the y values by a number bigger than 1, you'll see that the y-intercept moves farther away from the origin, and the line gets steeper. See how much steeper the blue line is? That's Q of X, than the red line. So hopefully that helps you conceptualize kind of what's happening. Great, let's move on. Okay, question number 3. So there's no designated video on this yet, though I do talk about this couple times in the blue playlist. So if you watch the blue playlist, you'll see me talk about this once in a while. The question says that we have infinitely many solutions. So my plan is I'm going to expand these polynomials and use a strategy called matching coefficients. So first, 3x minus a squared. That's 3x minus a times 3x minus a. So if you're unsure how to expand it, we should write it out like that. Lots of people, they would just do 9x squared minus a squared, and that's wrong. You can't use distributive law of exponents when there's more than one term. There's two terms, 3x and minus a. All right, let's FOIL both these then. So 9x squared minus outer is 3x minus a, so 3ax minus 3ax is the inner. Last is negative a times negative a, so that's positive a squared. The right side, 2x times jx, that's 2jx squared. Outer is negative 2kx. The inner is positive j times jx, so that's j squared x plus j squared x. And then the last is positive j times negative k, so that's negative jk. Okay, now to make, first of all, on the left side, we need to combine those like terms. So this is 9x squared minus 6a. I'm going to need a lot of room here. This is a long question, so let me make this a little higher. 9x squared minus 3 is minus 6ax plus a squared equals 2j x squared. And then I'm going to put the j squared x like in front, just so that I can have the negative seconds, that this looks a little nicer. And then what I'm going to do is I'm going to factor out the x to make it more clear to you guys what I'm about to do. Just kind of trust me for now. J squared minus 2k x. See how I pulled out the x, and then this is kind of weird. I put the common factor on the right just to make it look more like a quadratic. That'll make what we're about to do more clear. And then minus jk. Now, if it has infinitely many solutions, all the coefficients of each type of term must be the same. So I'm going to make a little table, and we'll do the x squareds. So I get 9, and on the right side, it's 2j. So 9 equals 2j. Now for the x terms, I'm going to do the coefficients of x. So negative 6a. And this one is j squared minus 2k. So I'm going to write minus 6a equals j squared minus 2k. And now I'm going to do the constant term. So that's positive a squared and minus jk. So let's do that in kind of pink here. So the constant is positive a squared is equal to negative jk. So very quickly, I can see that 9 equals 2j. If I divide both sides by 2, I get j equals 9 over 2, or 4.5. So that's important. I'm going to put a box around it. Now, these other ones, if I plug in j equals 4.5, and I'm going to put a box around these guys for later, because I might need those later. And let's put j in for 4.5. So I get negative 6a equals j squared. So that's 4.5 squared. That's 20.25 minus 2k. And then a squared equals minus j is 4.5, so 4.5k. And you see this is now a linear quadratic system. We have two variables. We can solve it. So let's see. My strategy is I really want to find a, so I'm going to substitute for k in the bottom equation. And I also really don't want to mess with this a squared because this is going to get messy really quick. So I really don't want to mess with this a squared. I want to figure out what k is up here and then put it into the second equation. That's my strategy. So let's look at the second one. I'm going to do negative 6a. And then for that one, I'm going to subtract 20.25 from both sides. So let's do that. So negative 6a, and I get minus 20.25 equals negative 2k. Now I'm going to multiply both sides by negative 1. 6a plus 20.25 equals 2k. And then I'm going to divide both sides by 2. So I get k is equal to 3a plus 10.125. And now that's the first equation, just rewritten. So now I'm going to take that and plug it into the second equation for k. So let's see here. I'm going to go down here. Hopefully this tells me my final answer. So a squared equals negative 4.5 times 3a plus 10.125. And now I'm going to distribute the negative 4.5. I get a squared equals negative 4.5 times 3. That's negative 13.5a. And then negative 4.5 times 10.125. That's minus 45.5625. And I get those all to one side, try to put it in standard form so I can maybe factor it. So I get a squared, add 13.5a to both sides, plus 13.5a, and then add 45.5625, plus 45.5625. And that's equal to 0. I just moved both those guys over to the other side. Okay, now what the heck am I going to do with all these decimals? Well, let's look over here. Okay, so 13.5, that is a denominator of 2, and 45.5625, that is a denominator of 16. So the LCM of 2 and 16 is, of course, 16. So to clear the denominators, we're going to multiply the whole equation by 16. So let's go and do that. So I'm going to multiply this whole equation by 16. And we should get 16a squared plus, what's 13.5 times 16? 216a plus 45.5625 times 16, 729 equal to 0. Now, I see that this guy looks a lot like a perfect square trinomial, which I go over how to factor these in my, sorry, not equals 0, equals a plus b squared. I go over how to factor these in my Ottocento number 4. Definitely check that out if you haven't already. So you see 16a squared, the square root of that is 4a, and then 729, what's the square root of that? 27. So it's going to be 4a plus 27 squared. See how I'm plugging it in over here? Again, go watch the Ottocento video on factoring if you're not sure what I'm doing. Equals 0. So now 4a plus 27 equals 0. We just got to solve that. We're done. So 4a plus 27 equals 0. I get 4a equals negative 27. Divide both sides by 4. And I get negative 6.75 which is also equal to negative 27 over 4. Either of those would be acceptable for the answer. So we could have saved ourselves a ton of work at the end by just like once we finish the beginning, just jumping to Desmos. So I'm going to show you guys that now. All right, so see these ones I put in the green over on the left side? So let's say I get J equals 4.5. And let's say now negative 6a equals j squared minus 2k. I'm going to just write that, but instead of a and k, I'm going to write x and y because that's my system. So negative 6x equals j squared minus 2y. And then x squared equals negative jy. And sure enough, this is a linear quad system with one solution. Let's see if it tells me what it is. Oh, negative 6.75. Okay, so x, which was a, is negative 6.75. And y, which is k, is negative 10.125. We didn't find that earlier because the question wasn't asking for that, so we didn't care. But I want to show you guys that we did indeed do it right, at least I think. Okay, so now I'm going to get rid of these. Don't care about those. I'm just going to get rid of those entirely. So now we have a, j, and k. So now we can go and plot the two quadratics in the original question, and we'll see if it gives us infinitely many solutions, and then we'll know we did a good job. So y equals left-hand side, 3x minus a squared. And y equals 2x plus j, jx minus k. Okay, let's see if I unhighlight the blue, unhighlight the red. It certainly looks like these two parabolas have infinitely many solutions. So it seems like we did a good job. Great, let's move on to the next question. Okay, question 4. Sorry about my work from the previous one, just try to ignore that. Hopefully you guys download the PDFs anyway of the worksheet. So let's see here. So they give us this equation up here, and then it says we're going to translate f of x 6 units in the negative x direction, so that's left, and then 2 units in the negative y direction, so that's down. So left, negative x direction, means h equals negative 6. And 2 units the negative y direction, that's down. That means k, the vertical shift, is negative 2. I go over all this in my Ottocento. I'll put it in the card. I'm pretty sure it's number 4 or 5 or something. It's on function translations. Definitely go check that out. This is an explicitly defined function. Y is by itself. So we are going to use the expression f of x minus h plus k. So g of x, the resulting graph, is equal to f of x minus h plus k. So change keep. The h has a minus in front of it, so he gets changed. Plus k, he gets kept the same because he has a positive in front of him. So g of x is equal to f of x plus 6 minus negative 6 plus 6. And then keep the sign of the one on the right, minus 2. And now we're going to use this equation they gave us up here, and we are going to replace the x with x plus 6, and then slap a minus 2 at the end. I went over this in the Ottocento video. Definitely go check that out if you don't know about function translations. It's on the digital SAT a lot. Okay, we get g of x is equal to negative a, x gets replaced with x plus 6, and then we have plus b, and that whole thing is like f of x plus 6, and then all the way at the end, it doesn't really change anything anyway. There's no like terms, right? So it doesn't matter, but you see like all the way at the end is a minus 2. So there's nothing to combine anyway, so those parentheses don't really matter. So it's just minus 2. So you see, f of x plus 6 is this part, and then the minus 2 goes over here after it. Okay, so this is great. We've got an equation for g of x. And now we're going to use the points that they gave us to figure out what a and b are. So an x coordinate of x-intercept of -3. Okay, so let's make a little table. So x and g of x. So an x-intercept of -3, so that's -3, 0. And then g of -6 equals 61 over 64. That's telling me x and y. X is -6. G of x, or y, is 61 over 64. So what we're going to do is we're going to try to think, which point should we use first? Well, I'm tempted to really plug in that -3, 0, but you see what happened, guys. If we plug in -3 for x, the a and b are both still there, so we can't really solve for anything. But if I put in the -6, then that exponent will go away and something will happen. So let's see what happens there. So I'm going to put in the 61 over 64 for y equals -a to the -6 plus 6 plus b minus 2. Great. So -6 plus 6 is 0. A to the 0 is 1, but it's multiplied by a negative. So that's really -1. Like this whole thing here is 1, but it's really a -1 because there's a negative in front. Anything to the 0 power is 1. That's one of your rules of exponents. Okay, so -1 minus 2 is -3. So this becomes b minus 3. And now I'm going to add 3 to both sides. And I'll just do that on a calculator. What's 61 over 64 plus 3? That is 253 over 64. So that is b. So now maybe I can go and put the b in and then plug in the other point and figure out what a is. Okay, so this equation becomes g of x equals -a to the x plus b minus 2, but b is 253 over 64, and 253 over 64 minus 2 is 125 over 64. So I just kind of put this in here, guys, and then did minus 2 to that. Okay, great. So now we're ready to plug in the -3, 0. So this is 0 equals -a. That's plus 6. So -3 plus 6 is 3. Running out of space here, guys. I'm trying to show less work. Okay, so if I subtract, why don't I just add a cubed to the other side? It doesn't matter. The negative's going to go away anyway. So I get a cubed equals 125 over 64. And now I will take the cube root of both sides to figure out what a is. And CBRT, 125 over 64. And I get 1.25, or 5 over 4. And both of those are the answer. Either of those are acceptable. All right, why don't we jump to Desmos and try doing this one using regression. So I'm going to put the points in. I'm going to make a table. And I'm going to do -3, 0, and -6, 61 over 64. And I'm going to type in our equation and regress it, the one in the blue box. So you still need to know what function translations are, but you could probably bypass most of this one. So y1 tilde negative a x1 plus 6, and I'm going to just put this all in the exponent. And plus b minus 2. And that looks great. So if I go on the next line and I want the fractional answers, 5 over 4, that's what we got. And 253 over 64, that's what we got for B. And sure enough, it looks really good. This is what we got for our graph. It goes straight through both those points. So it looks good. We got an r squared of 1, so we know it did a perfect job. For some problems like this, guys, maybe they didn't give you enough points to regress it. So don't rely on this too heavily. Make sure you know how to do this by hand, especially function translations. Great, let's keep going. Okay, question 5. This is a, it's got a lot of stuff going on, but this is primarily a scale factors question. So if you don't know what scale factors are, you need to go watch my Ottocento number 10 on area and volume scale factors. I'll try to put it in a card above. Definitely go check that out because I go over all this in great detail, and I'm just going to kind of assume you've watched it. All right, so they tell us that the ratio of AB to CD is 6 to 5. So a really neat thing you can do when you're trying to visualize some ratios is you can introduce a variable. How about x? So I'm going to call 6 to 5. So I'm going to call AB 6x, and I'm going to call CD 5x. That would be in the ratio 6 to 5. We don't know what x is, but it doesn't matter. This question is all about ratios and scale factors. So the center, it's the center. C is the center of both circles. So all of this is symmetrical. So I'm going to label this 5x and this 6x. So we can now figure out the length scale factor by comparing the radii or comparing the diameters. It doesn't really matter. I'm going to do the diameters just for the heck of it. So the diameter of the little circle is 10x. And the diameter of the big circle is 12 plus 5 plus 5. That's 22x. So the length scale factor, which we call capital K, is the big length over the small corresponding length, linear measurement. So I'm going to do 22x over 10x. The x's cancel. 22 over 10 is 2.2. It comes out terminating, so I'll use the decimal. If it were a messy decimal, I would use the fraction. So this is 2.2. So we just figured out something really important. Capital K, the linear scale factor, is 2.2. Now that we have that, the question is asking about area, so we can figure out the area scale factor. So the area scale factor, as I go over in my Ottocento video, is equal to K squared. And you might be able to guess, this is your first time seeing this, the volume scale factor is K cubed. So I did K squared, so that's 2.2 squared. Let's see what that is. That's 4.84. So the area scale factor is 4.84. So now they gave me the large area. The large circle is 242. So now to get, because remember, I made the scale factor big over small. So the small one, if you multiply that area times 4.84, you would get the big one. So to go the opposite way, I'm going to divide by 4.84. So the area of the small circle is the area of the large circle divided by 4.84, the area scale factor, the way I defined it. So 242 divided by 4.84, and the area of the small circle let's see what that gives us, is 50. Great, that came out really nice. Okay, so now we are going to find the area of the shaded region, like this kind of like outer ring around here. So to do that, we're going to do the encompassing area, in this case the large circle, and take away the unshaded area, in this case the small circle. So the area shaded is equal to the encompassing area, the enclosed area, minus the unshaded area in that enclosure. So in this case, that is 252? No, 242. Minus 50. And that gives us 192. Which is the correct answer. So you maybe could have gone and used the area formulas to try to figure out what x was, but the problem is you would get an irrational number, so it would be really hard to get the exact precise answer. And if you were even off just a little bit, if you put like, 192.1 or something, that would have been marked wrong because there's a clean exact answer to this question. Regardless, you're going to get conceptual questions. Make sure you know how to do area and volume scale factors by hand, and make sure you understand how to label a ratio onto a diagram by introducing some kind of letter. Great, let's keep going. Okay, question 6. So this one isn't too bad, but this is a topic I haven't put in the playlist yet, and hopefully you guys have figured out kind of the idea is that this is like this whole playlist is going to be one giant final review kind of topic for all the future students to come. And you'll see with these statistical study questions, I like to make lots of jokes about the channel. So Nepal is one of the top countries that watches my channel according to my analytics. So big shout out to you guys. Anyway, so it says a content creator, that's me, I know, right? Selected a random sample of 800 Nepalese SAT math students. The selected students were asked whether they approved of the change to a digital testing format, and 496 approved, blah, blah, blah. Which of the following is the largest population to which the results of the study can be generalized? So when you see a question like this, the first thing we're looking for was the sample selected at random? And it was. See, it says random. So if the sample was selected at random, which it almost always is, it can be generalized to the entire population. If it wasn't selected at random, which pretty much never happens on an SAT question, but you never know, is you could only generalize it to that sample, to that group of people you asked, but like 99 times out of 100, it's selected at random, and you can generalize it to the population. So that's first part, not that important. The second part, which is way more important, which confuses people way more, is what is the population? Well, the population is the group that you drew the sample from. So I drew the sample of 800 Nepalese SAT math students. So what we're going to do is we're going to take that number, the 800, and we're going to kind of chop it off. And we're going to just look right here. And we're going to plop the word all in front of it. So where it talks about the number of people that were chosen, we don't care just about those 800. We care about all of those people. That's the population. All of the people like that. So we want all Nepalese SAT math students, which would be answer choice D. And that is the answer. So red flag, A says in the sample. I don't even need to read it. I see the word sample, and I know it was selected at random. I know that's wrong. B doesn't make sense because I didn't select different types of students. I didn't select people who weren't studying for the SAT. I didn't select people who were older. I didn't select people who were younger than like around college age. So it's too broad. It would include types of people that I didn't include in my study. So this is wrong. It's too broad. And all SAT math students, that's way too broad. You could imagine. Wait, SAT math students, all of a sudden, that's other countries like USA, UK, Italy, Pakistan, India, you name it, right? So that's students from all over the world. So that's also way too broad. I didn't ask any of those people, so I can't generalize the study to different types of people. Even a tiny difference, like a different town or something, I can't do that, let alone across the world, right? So that's also way too broad. Again, you don't even need to look at the answer choices. Just extract the keywords for the population from the question like we did up here. Great, let's keep going. Okay, question number 7. Ladies and gentlemen, I am once again asking for you personally watching this right now, to go watch Ottocento number 6 on linear systems, how many solutions. Forget about SAT preparation. I think it's the most important video to watch on this entire platform. So please, please, please go watch that. I promise you, it's one of the most commonly misunderstood things / commonly tested concepts on the entire exam. So please go watch that video, even though it's long. There's a free worksheet you can complete that will help you understand this a lot better. There's even an example exactly like this one. All right, so here's what we're going to do. We're going to take that equation and we're going to try to put it in slope-intercept form. Both sides in slope-intercept form. So first I'm going to multiply, expand everything out, distribute. So ax minus 5a plus 4b, and then the right side is 7 times b, 7b minus 35x. So now I want to get these in slope-intercept form. So what I'm going to do is I'm going to rewrite the right side with just the negative 35x in front. That's just commutative property of addition. And I'm like, the right side kind of looks like slope-intercept form, but the left side doesn't. Now I'm kind of thinking, what could I move quite conveniently to the other side to make it look the same so I don't have to do any factoring or anything? And I'm seeing that I could quite conveniently move this guy over here and he would get absorbed into the 7b. So we're going to subtract 4b from both sides. So I get ax minus 5a equals negative 35x. 7b minus 4b is 3b. Great, and now that is our magic equation that we're going to use the concepts from the Ottocento video on. So we see in the question, it says that we have no solution. When we have no solution in slope-intercept form, as I talk about in the video, we know that that means it has same slopes and different y-intercepts. So, same slope. Let's do that first. So that's A, same means equal, right? A is equal to negative 35. Okay, that seems important. We're probably going to need that later. All good there. Now we're going to do different y-intercepts. So the y-intercepts are the constant terms on each side. So negative 5a and 3b. But they're not equal. We said different, right? So we're going to set them not equal to each other. That's called an inequation. You can do algebra on an inequation just like you can on an equation. So I'm going to put in negative 35 for a. So negative 5, negative 35, not equal to 3b. So negative 5 times negative 35 is 175. And now I'm going to divide both sides by 3. So doesn't simplify it. I get b is not equal to 175 over 3. And the question says b cannot be equal to the number m. So I'm going to write that down here. B cannot be equal to M. So you see, guys, M is equal to 175 over 3. So that is the answer. And I don't know why you would do this. 175 over 3 fits. I don't know why I would use a repeating decimal and risk the anxiety of getting it wrong. But if you wanted to, you could put 58.33. That would be 5 characters, and that would fit in the Blue Book app. There's only one answer because we rounded down, so rounding and truncating give you the same result. So you could put 175 over 3 or 58.33. Now, let's go and plot this on Desmos to see if we did it right. Maybe Desmos isn't super helpful for getting the answer because the answer was a messy fraction, right? And there was lots of variable. There was 2 constants. We would have had to make sliders for both of them if we weren't sure. But we can for sure check the answer. So let's do that. So let's see here. I'm gonna type in the left-hand side of the equation, y equals ax minus 5. I always break up the equation when I want to see how many solutions it has. Okay. And now I'm going to make a equal to negative 35. We know that must be the case. And I'm going to make b equal to, even though we said it's not equal, you'll see where I'm going with this, 175 over 3. All right. Okay. So when we make b 175 over 3, it's not no solution. It's infinitely many. So let's see what happens when we make it be something else. So let me do like, I don't know, 2, and then I'm going to do like negative 100 to 100. And you'll see that pretty much whatever I make it, as long as it's not 175 over 3, they're going to be parallel, which means they have no solution. See, they don't cross anywhere in the XY plane. So it seems like we did a good job. Great. Let's keep going. Hey everybody, thank you so much for watching till the very end of the video. As always, I wish you the best of luck on your exam, and I hope you can join me for my post-DSAT live stream, which will be Saturday, June 1st, from about noon to about 3 p.m. Eastern Time. When I first started the Problem Sette playlist, the goal was to make one worksheet for every single Saturday exam, so all 7 exams this school year, and we did it. So there are now 7 worksheets available, so that's 49 problems total that anyone can just boot up and log on for the beginning of next year and practice challenging problems to help prepare a week or 2 before their exam. So I'm really excited about that. I'm really glad we hit that goal. And I hope you hit your goal this upcoming Saturday. And I hope you have some good news to share with me when you join me at my live stream and my community tab. As always, best of luck. Thanks for stopping by.